Folks, Sega Sonic fan here. I was sent one of these new LCD design boards. These have been around for a while. This is the newest iteration of these cheap sort of backup camera composite video input LCDs, and I was sent this with the hope and dream that this would produce S-video quality output. But sadly, that is not the case. Just like the other one I have, this needs to have the firmware reprogrammed to accept an S-video signal. This is the older version over here, and I ran into the exact same problem, but there was some confusion on the forums. A really nice guy named Varenge sent this to me, but he was mistaken, I think, thinking that this actually supports S-video when it does not. I can show you. I can actually zoom in both on my microscope and on the board as to how this works. I'm actually going to use my microscope LCD because that's going to be easier to see. Bear with me. I'm also going to turn this off so I don't damage anything. Always a good sign. Good thing to do, I mean. And let's go over here. All right, you see this mess. This was not that fun to clean up, but first a little bit of background. Let me take the light off here. This chip, Techwell, you can see there, Dana, D-A-N-A 2 is one of the names, -CR. Let me try to get the lighting a little better for that. But the actual part number for this is near the bottom, which is a little unusual. It's the TW9910, so you can see there. And let's see. Yeah, it's about as good as I'll get the lighting on here. So the that's the chip, and originally developed by Intersil, who's called Renaissance or whatever, because they've been merged with another company. But basically, it's an Intersil NTSC encoder chip. It takes your NTSC signals and or PAL, I guess. It takes your encoded signals and turns them into a digital RGB output. I'm presuming this chip over here is a microcontroller, but maybe not. I haven't looked into that chip yet. Anyway, this has a bunch of built-in programmable settings. These modern chips are just tons of stuff built into one. I think it even has the TFT or LCD driver outputs as well. So about this mod, though, a couple things you need to know. This pin right here is ground. This is actually the output ground for your luminance input, your Y input, or CVBS. And over here, this is your YMUX0, which just means that's your original. You have 0, 1, 2, and 3. You have 4 MUX, 4 Y inputs that are multiplexed that it will select from depending on how you program it. And so this is the original input, essentially. That's your base input. For luminance and for, well, CVBS, which is what it's programmed for currently. So you have a 1 microfarad resistor here, or 100 NF, or I'm sorry, capacitor. Ugh, can't speak well today. You have a 100 NF, or 1 microfarad capacitor right here. And that is in series with FB1 right here. They actually fused the composite video input, which is kind of interesting. And then this also is, this FB1 also connects to this 75 ohm resistor. This is a pull down resistor. It's just a typical pull down resistor that you get in any television or CVBS input. So over here, this is your CVBS input. These two are ground, and this is your unregulated DC positive voltage in. The rest of these pins are for programming, and I haven't messed up with them yet, but I'll be interested to know what they do. OSD controls, I'm assuming. So let me turn off this light so you can probably see a little better. Yeah, so that's basically it. This pin right here is just another way to solder to FB1. If you look closely, you can vaguely see the trace that connects the two right there. Trying to find a way to make the lighting a little bit better here, but if I can get these guys. Okay, so yeah, so that's pretty basic. That goes through the fuse. And then after the fuse, it has this pull-down resistor, this 75 ohms pull-down resistor, and this 0.1 microfarad C13. I guess I should be using part names here. So R21 is the pull down resistor. C13 is the inline capacitor that turns the DC input, or I'm sorry, the AC input's already AC actually. So it just, I guess it's a frequency pass filter. Anyway, C17 I removed. It's actually not necessary. It's another capacitor that's just in parallel with C13. And yeah, so pin 11 here, that's ground. I forget what 12 is. 13, CVBS input. 14 is another, it's an analog ground. And 15 is chrominance input. Now, obviously, chrominance input is what we're interested in. The board that I received had this trace ripped up, so I had to repair it with this small bit of wire here. And according to the data sheet, the chrominance input and the Y input follow the same set of passive components. So you have another 0.1 microfarad in series and a capacitor in series and a 75 ohm pull down, which is what this is. This is just being tied over here, which is ground. So nothing fancy going on there. A little bit of stuff I'm going to clean off. But yeah, and then C19 does not actually need to be removed at all. C19 is just a decoupling capacitor for the 1.8 volt analog voltage stage. You can see that big V right there. That's the 1.8 volt analog voltage right there. So I wired in a chrominance signal right here, got my pull down resistor, got my capacitor, wired in luminance, and that's how I got the video that you saw earlier. Nothing too exciting. It's basically just looking for what it should be looking for, which is color and luminance on pin 13. Since it's not there, it's picking up luminance and it's trying to pick up color, but of course it doesn't look so hot. My guess is this was mistakenly thought to be S-video because with a 100 ohm resistor on the luminance signal, there's less color bleed into the luminance possibly, and also this could just have a good comb filter, so it might look better just as a circuit overall. But it is not in fact S-video. If you wire up chrominance to here, as was previously recommended, all you're doing is you're literally combining chrominance and luminance. If you're removing this capacitor C14 and C19, that's not really going to have much of an effect. And you're just putting in composite video. So yeah, I tried with S-video and color difference, and it looks like it's not working. And somebody will need to reprogram the firmware, which is over my head. But if anybody wants to work on that or point me in the right direction, I would love to do it, because this chip is perfectly capable of S-video. It's just not programmed for it. All right, that's it for this video. I want to thank Vrenj for sending this to me to hack on, and if anyone else wants to send me a board like this to come up with a nice S-video or RGB mod for the Sega Nomad LCD upgrade, I'd be happy to do it, because I want something other than composite. And yeah, we're all Sega fans. So yeah, this is Sega Sonic Fan, signing out.